anyway, good afternoon and thanks, Kalev, for the introduction. I really do wish I could present this talk in Estonian, but I'm afraid it's a language that I don't know, so we'll have to stay with English. I work at the Helen Hamlin Centre for Design. We've collaborated with professionals from different disciplines, from several partner institutions, to develop some innovative design solutions. I'll show you the ways that we work through some real-life examples of our projects and some of the many things that we've learned along the way about getting ideas to market. That was clever, wasn't it? That's it. I'm so sorry about that. This is what's called a glitch. Okay. We've collaborated with professionals from different disciplines, from several partner institutions, to develop some innovative design solutions. I'll show you the ways we work through some real-life examples of our projects and some of the many things that we've learned about getting ideas to market. I'll also share a few of the hard lessons that we've learned along the way, because by the end of my talk, I think you'll have seen some projects that are well researched, designed, tested and developed with end users. But there's actually quite a broad range of results in terms of successful commercialization. We're based in London and we're part of the Royal College of Art, where we're the largest and longest established research branch of the college. We specialize in people-centered design, and the essence of our approach is to work with as many users as possible, designing with and for them. This also involves industry, because as designers rather than academics, there isn't much point for us if our research work doesn't result in a marketable product or a service that reaches end users and actually makes a positive difference. To create meaningful design, first you must define the problem you're trying to solve. Design has become anything but straightforward since Jan Berntsen curated the Danish Design Council's exhibition in the 1980s. Creative self-expression has become prized above social purpose and utility. It's the celebrity phenomenon in a way, and too many designers have become far more interested in their own problems than other people's. The relationship with the self has taken precedent over the relationship with others. At the centre, our aim is to explore design that will contribute to improving people's lives. Through design research and projects with industry, we want to make a creative impact, but in areas of social need that are more complex and demanding than ever before. That's why we're so interested in using design methods to create better products and systems that make a difference in the real world, rather than solving problems that aren't actually really priorities. Do we really need yet another expensive lemon squeezer based on some momentary visual joke, for example? We do need to find answers to the challenges of keeping an aging population active so they can interact socially and economically, and making our health services safer and our workplaces more sustainable. We feel that these are problems that designers have some responsibility to engage with, and that they more urgently need our attention. The Centre was founded and financed in 1991 by Lady Helen Hamlin, herself an RCA design graduate, finding as her mother aged just how badly the design of so many products fails to consider their older people. Foreseeing the aging demographic that's now an urgent issue, the Design Age project looked at design for our aging population, and alerted industry and the design profession to the far-reaching implications worldwide. For Saab, we designed an accessible car for older drivers, and for Safeways, a jar that's easy to open and easier to grasp on the shelf. Since then, we've developed design thinking to address a range of social problems in the areas of 3 research labs. Age and ability, that's design for a more inclusive society, irrespective of age and ability. Workplace and city, research into changing patterns of work and urban life. And the one I lead, the Healthcare and Patient Safety Lab, creating better and safer healthcare services and products. The essence of the methods we use is to work with as many users of whatever we research and design together. With the involvement of industry, we can't make a difference if the design work doesn't result in a product, process, or system change that gets to market and is adopted. Before I joined the Centre in 2007, I worked for 30 years in design consultancy, and we designed whatever the client asked us to. Sometimes I joke about the briefs they would set, something profound like, it's got to be lime green next year. But our briefs are very carefully worked out. On this double diamond model of the design process described by the UK Design Council in 2005, the point where the design brief becomes defined lies roughly in the centre of the process. In consulting, that was where we were given the brief, however solidly or subjectively it had been established, and the project would usually deliver design concepts in 4, 6, or maybe 12 weeks at the most. Whilst I did work on some really meaningful medical projects, after a couple of years at the Helen Hamlin Centre, I realised that I'd spent 30 years working to many briefs that didn't have proper user research underpinning them. At the Centre, our projects are set up on longer timescales, starting with problem statements and research questions, rather than a prescription. Our Research Associates programme teams recent graduates from the Royal College of Art with an industry partner for 1 year. You can see how it maps properly now to the double diamond. The first 6 months are spent doing immersive research with users, then analysing it with users to create an evidence or insight-based design brief. We then co-design with those users, make mock-ups and prototypes, and then get the users to evaluate them. Then we use their feedback and iterate the process. And getting something right usually takes about 3 iterations. I'll talk about medical projects because those are the ones I lead. We came heavily involved with healthcare from 2003. The first project, Resuscitation, is one to redesign the resuscitation trolley. Now, several of these are kept in every hospital, containing all of the equipment necessary for the immediate care of a patient who is critically unwell, has stopped breathing, or whose heart has stopped. From 2005 to 2006, a total of 86 incidents involving resuscitation trolleys were reported to the UK National Patient Safety Agency. Of these, 13 had led to patient harm, and 10 were thought to have actually directly contributed to patient death. As we know, there is a tendency to underreport incidents, so it's likely that this represented just the tip of an iceberg. Most of these reports related to poorly stocked trolleys with vital pieces of equipment missing at the time of the arrest. In light of their findings, the National Patient Safety Agency decided to sponsor a redesign of the trolley, as despite clear guidance from the Resuscitation Council about stocking and checking resuscitation trolleys, these incidents were still occurring, and so reissuing the same guidance was unlikely to have much impact. They invited the Helen Hamlin Centre, clinicians from Imperial College and Bristol Maid, who are a large manufacturer of hospital equipment in the UK, to find an effective solution. As we ourselves are designers, we knew little about resuscitation or resuscitation trolleys. So before we even began the research, we had to look at what the trolley is to understand the product and the role it currently plays in the resuscitation attempt. So we assessed current products. These crash trolleys first appeared in hospital wards in the 1940s and 50s and were essentially modified tool chests. At the time, these provided space to contain all the necessary equipment and were easily wheeled to the scene. Since then, particularly with the advent of cardiopulmonary resuscitation, that's CPR, in the 1960s, the science of resuscitation has progressed enormously. The trolleys, however, have not. Out of this selection of trolleys, shown here, 2 are actually car mechanics trolleys, and they're not adapted for medical use in any way. Crash trolleys have never been specifically designed for their purpose. The result is that they tend to become a general dumping ground. Clinicians often place additional equipment on the trolley, or worse, take something away when they can't find it easily elsewhere in the ward. The general chaos of the situation means that in a real emergency, it's really hard to find what you need, and what you're looking for might not even be there. The NPSA report specifically identified that properly stocked trolleys led to harm or even death to the patient as staff frantically try to locate the equipment required. Time is really of the essence. Here, it takes an intelligent, motivated doctor from our own team 18 seconds there and 6 separate attempts to find the catheter that he's looking for. In this case, it's the design of the trolley which is clearly at fault. He's a bright guy. Having got to grips with what a resuscitation trolley is, the actual process of resuscitation had to be understood before a design solution could be developed. Designers, clinicians, and psychologists in the team built up a picture by reading the relevant literature, interviewing resuscitation team members, attending advanced life support courses, and even witnessing real-life resuscitation attempts. This helped us to map out the complex system of resuscitation, along with the demands on products at every step in the process. Failure modes and effects analysis, which I'll come back to in the next project that we'll be looking at, was useful in identifying all the key points where design could make a difference. For example, sometimes the drawers don't open properly, limiting access to the equipment. It's hard for more than one person to access equipment at the same time, and trolleys may be stocked incorrectly or insufficiently, compromising the resuscitation attempt. Everyone was then encouraged to think as radically and creatively as possible, and a huge number of concepts were generated based on the research. From this range of ideas, one concept was selected. This first prototype, or mock-up, splits the equipment into 3 areas of clinical activity: airways and oxygen, cannulation and intravenous drug delivery, monitoring and management. So the clinician concentrating on each particular activity can take the relevant section of the trolley to where it's needed. One of the factors in a successful resuscitation alongside speed is the rapid formation of a team with a designated manager who is understood to lead the team, and the division of the trolleys has been shown to help promote that behavioural change. At this stage, the prototype won a first prize at the Medical Futures Innovation Awards. This helped to raise the profile of the project and enabled further development, because it allowed us to approach manufacturer Bristol Made, who became involved to ensure that the next prototype was a feasible commercial proposition, as their design for manufacture and engineering capabilities and huge experience of supplying the National Health Service were vital in moving to the next development stage. We continued to run user feedback sessions with a number of clinical staff, which led to suggestions for design improvement in terms of user factors. The suggestions incorporated were a more robust splitting mechanism, security blinds for the equipment, and a better layout. The features of the new trolley are the open layout. All of the equipment is seen at a glance on the exterior, making access easier and reducing time spent searching for it. Labelled storage places helps with the stocking and identifying of equipment. Logical equipment layout with immediately needed items such as the face mask at the top, gradually working down to items needed later in the resuscitation attempt. The security blinds that are pulled up and secured, preventing doctors from stealing things when the trolley is not being used. And the 3 sections enable equipment to be taken to the relevant part of the patient. Having developed that prototype, the next step was to test whether or not it made a difference to the resuscitation process. We won funding from the Wellcome Foundation for clinical trials, and the results in brief are these. The time to locate the equipment, significantly faster. No reports of missing equipment. Using the old trolley, 4 of the 15 participants were unable to find equipment. And on average, there were just under 7 unnecessary drawer openings per attempt. User feedback highly preferred the new trolley in all aspects, and team performance was equally good on both old and new, despite the fact that the team knew nothing about the new design, but were very familiar with the existing equipment. What about commercialization? Well, in summary, the manufacturer has now concluded that this product cannot compete with trolleys mass-produced from car mechanics' tool chests, and certainly our own hospitals resist buying any better solution if it costs more than the existing one that they have. It also has to be said that during our work on the project, the number of hospital arrests has reduced enormously. Now, why is this? Well, it's because they've realized that assessing patients to see whether they're at risk of an arrest means they can be more closely monitored. It allows low-cost preventive measures rather than expensive treatment of problems when things have gone wrong, and then having to intervene with the resuscitation when it's too late. So it's sort of not a bad result in an indirect way, but so far this product is not in production. Second project, DOME, Designing Out Medical Error, investigated the problem of medical error, prioritized the areas and processes that needed to be addressed, led a multidisciplinary team to propose design solutions to support better processes, and evaluated and developed the best of the ideas towards commercialization. In up to 10% of all hospital admissions, some kind of adverse incident occurs, more than half of which are believed to be avoidable. But as well as the terrible impact on patients and staff, in the UK alone, the consequential costs are more than 2.5 billion euros per year. So we really do need to improve all aspects of patient safety. This is what hospital wards looked like in the time of Florence Nightingale in the late 1800s. In the UK, things haven't changed much. DOME is a collaboration between designers, clinicians, psychologists, and business experts, using a systems-based approach to research, to develop an evidence base and design better hospital equipment, environments and processes to improve patient safety, tackling the problems from the viewpoint of multiple disciplines. I'm going to take you through our process, which mapped the journey of the elective surgery patient through observations and surveys carried out with the patients and staff in a large London hospital. The purpose is to identify where errors occur and provide focus for a design intervention. One important thing with multidisciplinary work is that each discipline has its own culture and language, and each may interpret even the same word differently. In order to truly work together, a common understanding of philosophy and language does have to be developed. It takes a little while to do this, and we found that by illustrating or mapping a common platform in this way, it became possible for everybody to understand a framework for the project. Our focus is the bed space, but to improve it, we have to understand it within the context of the broader system. We undertook 70 hours of observations in 5 general surgery wards. We studied 60 activities, 10 healthcare processes, and we enlisted 60 patients and staff to feed into the research. It's important to pause at this stage to add that it's very important. We also appoint an advisory board for these projects. And this is made up of influential experts from clinical world, hospital management, procurement, safety, maintenance disciplines, etc., as well as patient group representatives and manufacturing and commercial specialists from industry. In this way, we ensure that not only do the eventual designs reflect the needs of the various users, but they remain rooted in commercial reality. This promotes buy-in, confidence, development assistance, and eventual adoption. Processes such as hand washing were observed in great detail in order to draw a map of all the steps, like this, checking with more observations, analysis with ward staff, and process experts who have particular knowledge in this area. We asked them also to brainstorm all the ways in which each step of the process could fail. Remember that we're trying to make design interventions that reduce medical error. We then used failure modes and effects analysis, used for many years in industry, but only recently in healthcare, to analyze the various processes. To do this FMEA, we bring together a small group of staff and patients to study the process map and rate each step in terms of severity, frequency of occurrence, and detectability. Multiplying these factors together results in a hazard score and reveals which stages of the process contain the most risk. As in industry, risk assessments are performed on processes to prioritize them according to perceived risk, then further analyzing them to improve the riskiest ones. The tool that's used is a hazard matrix. Processes can be rated quickly by people working in the environment, and the ratings can then be used to prioritize the processes. Our rating scale was similar to the industrial one, except that we added detectability, which is the likelihood that the error will be noticed and prevented from causing harm. So in other words, if an error is hard to detect, that means it has a higher hazard score. Believe it or not, hand washing is shown to be the most hazardous process, followed by monitoring patient blood pressure, pulse, temperature, etc., then documenting and interpreting those. Isolation of infection to prevent the spread of infection from one patient to another. Medication delivery and staff handover, the process of communicating information about patients when shifts change over. We compared published incident data, questionnaires and observations, and these processes, these 5, became our 5 priority targets. So if we look back at our double diamond model, you can see that we've researched to understand the environment and observe what happens and what can go wrong, and then analysed our findings to provide us with an evidence-based design brief. Now, these briefs are very important. They have to address the problems, and they also have to encourage creative thinking. We have to inspire all of the disciplines in the co-design group to think like designers. That's clinicians, psychologists, management specialists, patient group representatives, etc., from the research team. Working to carefully considered briefs, we worked as a team with those people to dream up ideas. We used classic creative techniques, for example, leaning on Edward de Bono's work to help our colleagues to tap into their own design creativity. It's important to get as big a breadth, as many as possible ideas for each brief. And the ideas are communicated back to the users through frequent sessions with frontline staff and in the ward with patients, doctors and nurses. Feedback was used to guide design direction, allowing us to move to sketch stage and iterative development of each brief. Now we come to the design interventions that have emerged in response to what we learned. The prioritised areas steered us towards the most productive directions for design activities. It's all about designing something that makes a difference in the real world. We thought about ways of defining objects or systems that could address several problems at once. I'll just describe some of these solutions now, or one in particular. The creative step is this. If you imagined a product that addresses groups of equipment and activities that are found in all 5 challenge areas, that would be perhaps an interesting direction to pursue. You might call that concept a care station. One reason that people don't use the alcohol gel, hand gel, washing gel, is that it's seen as a nuisance or difficult to access. On closer inspection, it appeared that equipment in the bed space is scattered around without a defined location. One patient said, "That's all you see, isn't it? People running from one side of the bed to the other, saying, 'Get me this, get me that.'" The patient medication locker often has a patient table in front of it. Doctors have nowhere to put their sharps, needles and so on, once they've finished with them. Gloves and aprons are usually not anywhere near the bed. And finally, there's no flat surface for filling in forms or reading notes. So here's the first rough design model of the care station. The initial prototype hooked over the end of the bed. It's got a flat surface for writing, provides gloves and aprons for contact precautions. There's a lockable medication box. There are wipes and a hand gel dispenser, and it includes the sharps bin. It was extensively tested by over 100 respondents across the London group of hospitals, and the manufacturer, Bristol Maid, was engaged to produce a second iteration incorporating those user suggestions. It's on wheels, it's not hooked onto the bed, and it includes a clinical waste bin. We put this through simulation trials, and user response and expert feedback was excellent. 6 prototypes for the clinical trials were built by the end of the project. Trials showed us that there is far less walking around, and you can see from the right-hand image that the time and the energy of the nurse is saved when using the care centre. It's now a product on the market, made and sold by Bristol Maid. To us, it's definitely a success. And now, our ambulance work. You remember that I said that the National Patient Safety Agency developed teeth after our initial study into safety and how design should be used to help improve it. They'd noticed a sharp increase in adverse incident reports from ambulance services, and the turning point was an accident where a young woman with a medical problem and psychiatric complications decided to get out of the ambulance, sadly, when it was rushing her to hospital, and she was run over and killed by her mother following the ambulance. Whilst the NPSA knew that design shortcomings might be a contributing factor, they needed help to understand the true nature of the problem and some ideas as to what could be done about it through design. So we started work in 2005. Our research showed that ambulances have evolved incrementally from horse carts used in the Crimean War to carry away soldiers injured at the front line. Nobody seemed to have stood back to think what the treatment space should be to support current evidence-based scientific clinical thinking, which has progressed almost beyond description since that time. And what we have today is lousy, badly laid out, unergonomic. It's a cobbled together collection of dirt traps and frightening hazards, both to the patient and the clinician. We identified 10 design challenges, that is, areas where design intervention could improve safety. The work fed into an ambulance standardization program. Until 2006, there were 29 separate UK services buying inconsistent designs, all different, according to personal preferences. Now we have 11 trusts, of which 5 or 6 are actually procuring to the same specification. So we've made a little progress. The other great outcome was that we were able to win research funding to take on a broader system-scale challenge. UK government had taken an initiative to train advanced paramedics, or emergency care practitioners as they're called, beyond usual ambulance crew skill levels, but had not thought about better equipment to allow the benefit of those additional skills to be exploited. With fit-for-purpose vehicles, kit bags, treatment spaces, diagnostic and communications systems, advanced paramedics would be able to attend a patient, diagnose the complaint in the same way that a doctor would, administer more powerful drugs, and treat and discharge the patient where they are, rather than simply taking patients to hospitals as before. Now things became very interesting. We looked into the composition of all UK emergency ambulance calls, and about 60% of them actually don't need the patient to be taken to hospital if basic equipment is in place to treat in the community. A third of those calls currently don't result in a visit to hospital anyway, because the problem resolves or the patient refuses to go and is considered capable of making that decision by the ambulance crew. But simply by reducing unnecessary emergency department journeys by 2%, we found that about 40 million euros could be saved UK-wide every year. So instead of this, where we have expensive, heavy, fuel-guzzling vehicles often overloaded with equipment beyond their legal weight and the driver's license limits, milling around taking a lot of patients to hospital who really don't need to go there, we could have this, an integrated system of different vehicle types, small solo responder vehicles, motorbikes, bicycles, as well as traditional ambulances, with standardized treatment spaces, modular treatment packs, improved triage and operations management, treating in the community those complaints that can be handled more safely or better in the community, and only conveying to hospital the patients that need to go there. Our proposition coincided with an emerging vision called the poly system, less monolithic hospitals complemented by local clinics, walk-in centres, and specialist stroke, cardio and trauma units. So we start to see an alternative solution where we don't just take straight to hospital nearly every patient, just the ones that need emergency care. Here are some concepts, some are crazy, but others could be put together to make a whole system. We still need to develop some of these ideas. Further research and detailed design of the little single responder treat and discharge vehicle, top left, perhaps with an extending rear pod, a treatment kiosk that can be placed at a shopping mall or a sports event, and of course the detailed operation of the whole integrated system. Overall, this is a very complex job, and money is not freely available. Maybe it is, I don't know. But you can still make a start somewhere, which is what we've done. This is to take step one with the detailed research and design of a key part of that system, a redesigned ambulance. Now, people can easily see the value of improving something they know, and this is something we could deliver within limited cost constraints, money that we could allocate from the centre, supplemented by UK regional innovation funding. The work started with ride-outs on duty shifts, 12 hours in the vehicle with a large number of crews, coordinated by our research paramedic, Dixie Dean. Fantastic. Clinically led by Professor Jonathan Benger, who's a leading UK emergency and pre-hospital care specialist, an air ambulance and emergency department practitioner. So he's an academic, but he gets out on the road or in the air 2 days a week. We studied various treatment spaces. Here you can see that the stretcher is locked against the right-hand side, the top of the treatment space. So the clinician can only get access to one side of the patient and has to reach over to get supplies and dispose of used sharps. We defined exactly what kit and supplies were needed during the work shift and identified various modes of use with the clinicians. Here's make ready, loading and checking the vehicle before the shift. Arriving at the scene, I have to be quick here. Loading the patient, it's complex. Critical care, and finally transporting the patient. We built a simple full-size representation of existing ambulance spaces and played out various treatment scenarios with the clinicians. Together, we considered what might be good ergonomic layout alternatives and positions for equipment and consumables, initially just using name cards, then scale representations. We realized that nearly all the equipment could be located in one working wall, leaving the other side of the space clear. And it was exciting when we realized that in the bottom picture, this gave us room to relocate the stretcher in the center so the clinician can actually get 360-degree access, which is one of the objectives that came out of the 2005 project. We find so often through the co-design process that everyday workers can bring really great insights as designers and ergonomists. The crews refined our layout ideas in a number of stages so that together we're able to create a really solid design brief that's truly evidence-based. Through a period of sketching and 3D modeling, we produced 5 or 6 interior concepts, distilled down to 1, through feedback from 36 frontline crews. Our evaluations were based on back-to-back comparisons using a vehicle loaned by London Ambulance Service and a static test rig built to our design. We used 2 clinical scenarios, carefully designed to test our attempts to improve efficiency, ergonomics, infection control, and patient safety, taking each crew through the same scenarios and like-for-like evaluation of results through video recording, logging, and analysis. The first scenario treated and applied a fresh dressing to an MRSA-infected leg ulcer that has started to bleed. The second was to treat a patient who is non-responsive and goes into cardiac arrest. We also made a screen-based simulation of our digital diagnostics and communication system. This allows better road navigation, access to patient records, direct logging of patient observations, and transmission to the receiving hospital. There's also a video link for discussions with specialists at the hospital, real-time stock control, and so on. This is all realistic. If you look at what a smartphone, your laptop, or a car engine management unit can do, it just needs putting together, but it would just transform the ambulance. This is how the design looked at that time. Central stretcher position, equipment laid out on one working wall, modular treatment packs, the monitoring diagnostic system on a sliding overhead rail, better lighting, hand washing facilities, and lay-down space. We carried out 2 further iterations of the development process, taking lessons learned and feedback from the crews to target areas for improvement, to work out design changes together and rebuild the rig and retest. For the third rig iteration and evaluations, we committed to a design freeze, a trailer-mounted demonstrator unit showing the interior very realistically and robustly enough for it to be taken around the country for all the services to evaluate. We had a real stroke of luck that saved us a massive amount of money. A decommissioned box module, which was the perfect structural starting point, came up on eBay one Saturday morning. And I jumped and won it for €450. Fantastic. This is pretty much the design as it is now, filmed through the final evaluations. All of the features that I mentioned and a clean, spacious working environment with smooth radii everywhere instead of little gaps and corners to collect dirt and sabotage any attempts to improve infection control. Here's Professor Benja with his ultraviolet torch picking up on a wipe mark invisible to the naked eye. The fake blood on the actress's very realistic bleeding ulcer was loaded with UV-sensitive powder. And here are some results. 30% fewer contaminations, about 60% fewer incidents that are likely to lead to contaminations compared with the existing vehicle. Shorter elapsed times to achieve treatment objectives, and slightly improved scores in overall technical skills. Here's what the crews have said. It's all pretty satisfying, but in a way, weren't we always more likely to find solutions they like, since our starting point was to ask them what are the things that give them difficulty, and then watching them working. At any rate, this is the demonstrator unit at the launch event that we ran. Our biggest supporters are photographed with the design team here. It's true that our ambulance can be built at lower cost than the vehicles we're replacing, and it delivers benefits in terms of infection control, clinical efficiency, and effectiveness. It's a bit lighter than current vehicles too, and proper use of the modular treatment packs containing no more and no less equipment and supplies than are needed for a work shift means that the vehicle need not be overloaded. So we can improve on the awful fuel consumption of the vehicles currently in service. But the major cost saving is in just not making the needless, expensive journeys to the emergency department, because we instead treat that majority of call-outs at the scene and discharge the patient there. It's a more satisfactory result in any case for patients who would rather not have to go to hospital, as long as they can be properly treated in the community. There's more to do, the little vehicle and the big system. We're committed to continue with this work. The major missing ingredient is really just the money to do so. But in the meantime, we're negotiating collaborations with some potential manufacturing partners and jointly working on applications to raise funding to develop working prototypes that can be tested in real service situations. The lessons learned from those evaluations should surely provide the foundation to commercialize our designs and start making a difference. So it isn't commercialized yet. That is a long, long job for political reasons that would take me at least 2 more hours to start to explain. But we progress in hope and confidence. The final project, I think I have 4 minutes, 40 seconds, is very interesting for today's meeting, I think. It's a cervical collar or neck brace. And we've worked with clinical academics, frontline ambulance staff again, and a medical engineering company. If you're unfortunate enough to have an accident and the ambulance crew think you may have an injury to your neck or cervical spine, they will want to immobilize the neck and take you to hospital to protect your spinal cord from any further injury. This is what a cervical collar or neck brace looks like. It's adjustable and is slid round your neck to hold your head still. Here are some photographs to show the various modes of flexion and extension of the neck. The disturbing thing is, anybody spotted it? Top, no neck brace, bottom, neck brace. There's hardly any difference in the angles of movement, whether the collar is fitted or not. It's not very effective. Clinicians have been getting concerned about this poor immobilization issue for some time. But more than that, the collars can restrict blood flow down from the head, which can raise the blood pressure on your brain and cause serious secondary neurological problems for the patient. Also, for an elderly patient or somebody with fragile skin, collars can cause pressure sores if left in place for any significant time. And furthermore, collars restrict access for the clinician to examine the neck and for radiologists to take x-rays. And bizarrely, the medics are actually expected to remove the so-called immobilization collar to examine or move the patient. So here are some of our user stakeholders who want to get a better solution and got involved with our teamwork. And top right, there's an x-ray showing why the collar has to come off for imaging. Here's our design. Why squeeze the patient around the neck when you could hold the top of the head and take a support structure down to the shoulders and chest? It's adjustable in length because humans come in such a wonderful range of shapes and sizes, and has a rear piece made from a flat, flexible sheet of plastic that becomes a 3-dimensional, stiff, rigid restraint when folded. So you can slide it under the neck and flex it round to meet the front part. It flexes outwards to fit a wide head and inwards for a narrow one. We can fit nearly everybody with one size, not 3. We've worked with firemen and ambulance crews to do simulated extractions from vehicles and produced proper peer-reviewed research data that demonstrates how the design works better and why it is designed as it is. We've also done expert detail design to make the parts easy and cheap to manufacture, and filed a patent to protect the product for 16 years. So here, you've got a really great product that protects a potentially injured neck significantly better than existing collars without raising blood pressure in the head. It gives better, proper access for X-ray imaging and examination, is comfortable for the patient to wear and easy for the paramedic to put on the patient. It costs about the same to make as existing collars. Okay, but all 4 of the leading manufacturers of so-called neck braces have declined to take forward the product, which needs very little further work in approvals and engineering to get it ready for production. They all say, cervical collars are a low-cost commodity product with low profit margins, and they are not, I'm sorry, lost that, wrong button, with low profit margins, and they are not a current development priority for us. It's unbelievable, these things are sold by the million. It seems that industry is comfortable with the status quo and propositions that do not require any courage or entrepreneurship to progress them. They're clearly not so comfortable when it comes to thinking about clinical value and the safety of patients and so on. Time will tell whether enthusiastic recommendation by leading clinicians will create a market demand, and this is what we're pursuing now. So again, this is not commercialized yet. So, some thoughts to finish. Beyond the basic, and we are now just over 45 minutes, beyond the basic stuff of putting the user first, which is what my centre is about. As you know, the user can actually mean a large number of people involved in making, selling, buying, maintaining, and even disposing responsibly of a product, as well as the consumer, the patient, the clinician, and whatever. We also need to work with other disciplines than our own. We have to put together the best team possible to ensure that there are no overlooked gaps of capability or viewpoint. And beyond getting the brief right with our users, co-designing with them rather than for them, and repeatedly testing the design and accepting criticisms as a means of making something better. These are all key points for fruitful collaborations between academics and industry. It takes time to build up the relationships and cultural understandings between the disciplines. Well, that's all point number 1. Point 2, the collar shows that even if you think you have something that's fantastic, but the manufacturers can't or dare not see commercial benefit, you may be stuck until the market screams at them that the product is wanted and valuable. In which case, you did take care of intellectual property rights in a fair but robust way with your collaborators, didn't you? And finally, point 3, it always takes longer than you'd hope to do it. As has this talk. Thank you again for listening. I think we probably haven't time for questions, but I'm happy to talk to anybody later. Thanks a lot.
Let's give an applause to Ed.